Hello, Ovesen.net. This is part 4 of my series about controlling electronics from the Commodore 64 support, and this episode I will take a look at different displays. Before I continue with the series, I thought I'll show you a few of the kits I use. First of all, I have this Arduino Starter Kit, which I bought here in Norway for around 60 euros or something. It contained one Arduino Uno, and it has a projects book, and it has all kinds of different components, LED switches, transistors, and capacitors. It has one of the displays I'm gonna show you today, and breadboard, jumper wires, yeah, a lot of things, servo motor. Also, I got a few other kits that I found on eBay, and these were very cheap. I think like 10 euros or lower. It also contains some stuff you can use for simple electronics. This also, it's made for the Arduino. It has a breadboard, the 7-segment display, things like that. I also got this handy little power supply that you can plug right into a breadboard if you don't want to use other power supplies, and you can plug directly into a USB power supply or a computer. I also got this kit of ready-made jumper wires that are cut to different lengths and color coded, so it's really handy on breadboards instead of using these fairly long jumper wires like this. Finally, I want to show you this Arduino Nano, which is an even smaller Arduino device with the same microcontroller, but it has less pins and less functionality, I guess. I didn't test this one yet. Alright, back to what I want to do in this video, and what I have here is 3 different display modules. The smallest one here is a small OLED display that are capable of displaying graphics and different colors. This one is made for the Arduino. Same with this LCD display. This is just for displaying 2 lines of text, 16 character times 2, and it's also made for the Arduino, and it is just one color. This one here is an LCD display with touch capabilities. This one is actually made for the Raspberry Pi, but I think it's possible to use it on the Arduino as well, but I'm not sure. I didn't test it yet. So what I want to do is to use the Arduino to control the displays, and use the Commodore 64 to control the Arduino and what it's outputting on the displays. I'm gonna start with this character display, which came in the Arduino Starter Kit. However, you can buy this separately, very cheap, around 2, 3, 4 euros, I guess. These are quite common. So this is quite easy to hook up. It has a few pins on the back side, and these are the pins for the power and the communication, and all the pins are labeled, as you can see here. So I already made the circuit that you need, so it's just a matter of putting the display onto the board here, and we're all set to go and try to test this. The circuit for driving the LCD display is easy. These two wires here gets the power to the LCD from the Arduino, the plus 5 volts and ground, and the other lines here are for sending data to the display. And also here we have a potentiometer, which is used for adjusting the contrast on the display. So if I turn on the Arduino, gives it the power, it should start up and power the LCD display. And as you can see, it does. It already has some text. It's upside down, sorry about that, but you get the point, and I can adjust the contrast. Controlling the LCD display from the Arduino requires a small program, but it's a very simple one. You have to make sure that you have the correct library, because you're not programming all the communication with the LCD display yourself. You're getting help from a library. In this case, it's a library called Liquid Crystal, and as you can see, it's already installed, so we're good to go. So in order to use the library, you have to include the library, and then you have to create a liquid crystal object, in this case the LCD variable here, and in the constructor for creating this object, you enter the different pins that are used by the LCD display, and then you just call in the setup LCD begin. You indicate the number of characters and lines. This one has 16 characters and 2 lines. Then you can just print the text to the LCD, and to print text on line 2, you move the cursor down and set it to 0, 1, and 1 indicates second row, and then print the text on that row. So quite easy. Alright, so I want to send a string of characters from the Commodore to the Arduino and then to the LCD display. But how am I going to do that? Well, we already know that the user port has 8 pins, and the Arduino has a lot of pins, so we need to send the data on the 8 pins from the Commodore to the Arduino. So we need some sort of protocol or scheme to send the data from the Commodore, and the most common way to transfer text or characters is by using the ASCII values. And here is the ASCII table, and as you can see, every character and different symbols are represented by a decimal value. So we're going to send one character at a time in sequence, and if we start with the letter capital H, we need to send a decimal value of 72. So we are sending the letter H, and that is decimal 72, and we need to find the binary representation of that number. And to do that, you can use a calculator, or you can go to a web page like this, where you enter a decimal number and get the binary representation. So we need to send these bits here, which means we're gonna send on the first line a 0, second line 0, third line 0, fourth line a 1, and fifth line a 0, and so on. After we have sent the first character, the H, we're gonna send an E, and if we look at the ASCII table for E, it's here, 101 decibel. And the decimal value of 101 represents the binary value 1000101. So we can start we can start sending this number. As you can see, we are only using 7 of the 8 output lines on the Commodore user port, and the reason for that is if we take a look at the ASCII table, the normal ASCII table is only up to 127, so we only need to use 7 bits. The extended ASCII codes are special characters that we're not going to use in this example. However, the 8-bit can be used to our advantage, because we are sending pulses on the output lines, and we need on the Arduino side to be able to time the input on that side. And how are we going to do that if we don't know how quickly the different bits are coming over the wire? But I'm going to use a very simple method, which is that we're actually creating a clock signal on the sender that are sent along with the data to the receiver. So that we will use the 8-pin to, and for every bit or value we are sending on the 7 other lines, we are gonna put the a 1 on the 8th line, so it will be a clock signal like this. So every time the 8th line goes high, we know that we can read the data from the other lines on the receiver. Alright, I have rearranged different wires a little bit. I'm using pin 2 here as the clock sync, and the rest of the pins up to pin 8 here is for the LCD. So then we only have 5 pins left that we can use, and since we need to use 7 pins in order to send ASCII data, we have to do a trick. I could of course use pin 0 and 1, but those are meant for serial communication, and if I use those pins I cannot use the serial debugging. Instead I'm gonna use only 4 pins and gonna send only half a byte at a time. That way we can just combine the 2 parts into 1 byte at the receiver. So let's do the programming for the sender side, which is the Commodore 64. I start by just planning out what the program should do, and first thing it's gonna do is to take a string input, hello world for example, then it's gonna take the first byte of that string, which is the H, and convert it to bits. And then send 4 bits at the same time send the sync bit. Sorry, I'm fiddling with this keyboard. I'm not too used with the Commodore keyboard. It's been a long time. Send next 3 bits plus sync bit. And then just repeat until end of string. So I made a little basic program to get some text as input from the user, then converting the different characters to the bits we need to send on the user port. I'll just walk through it quickly here. Line 10 asks for an input, enter text, saves that text in a variable $. Then I loop through 1 and until the length of the text in line 30. I take out the character, and in line 40 the character at that position. And then I convert the character to a number, which is the ASCII number for that character. Just to print. Then I just take out the first 4 bits of the number n, which I do by doing a bitwise AND with 15. And 15 is 4 ones at the beginning of a byte. Line 85, I get the second part of the number n, and I do a bitwise AND operation with the number 240, which is the 4 last bits of a byte. And then I print out those values. So let me try and run that program. And I just enter the text A, B, C. And the program calculated 2 different parts of each character of that string. So now this program is ready to send this data onto the user port. So that is the next thing. Now I cleaned up the program a little bit, and if you remember, I mentioned that I want to use the last data line as a clock signal, and I actually added the code here in line 81 and 86. I OR the value. It's a bitwise OR with 128, and 128 is the last bit of byte. So by ORing with 128, you turn the last bit high. What's remaining now is to actually put the data onto the user port, and I do that by the same poke as before, to set the register at address 56577, and then the value P1 to send the first part of the character we're sending. Then I want to set everything to 0, so we set the clock pulse to low. And when the clock pulse is set to low, the other bits don't matter. So next step is to send the second part of the character. And again set all the lines to 0. Alright, that should be it. Let's run and just test that the program works without hooking it up to the Arduino. Alright, Syntax error. I forgot to type 2. No, maybe 1000 was a little too slow, so I'm gonna reduce that to 500. Also, I needed an end statement before the delay subroutine, so that the program doesn't continue into that when it's finished. Now let's test. Alright, then it's over to the Arduino and try to receive this data. Now I have cleaned up the sketch a bit and put labels to each the pins and reorganized the pins I'm going to use on the Arduino. For the sync signal I'm going to use pin 2, which I call the C64 interrupt. And the reason for that is that I'm going to use a handy feature in the Arduino, which is actually an interrupt. So I set the pin mode for the interrupt pin to input the power up. I'm not going to go into detail on everything here, but the thing is I'm going to add this attach interrupt call here, which sets up the pin used for interrupting the program, and then a function to interrupt handler. And we want this one to be called when the pin is rising from low to high. So I'm gonna connect the pin 2 on the Arduino to the last data line on the user board of the Commodore. And each time the Commodore changes from low to high, this function here, clock interrupted handler, will be called. And if you see down here, this is the actual function, and these kinds of interrupt handlers shouldn't do any lengthy code. So only thing I'm doing here is to set this global variable clock was triggered to true. Then inside the loop function we check if the clock was triggered equals true, and if it is, then immediately set it to false. And then I'm reading the values of the 4 different pins. Now, since we are reading 1 byte value in 2 different parts in sequence, I have to keep track of what part I am reading. So I have a variable for that, so I can check if first part red equals false. Then I read in the first 4 bytes. And of course then I set first part read equals true. Then the next time the loop is called, first part read is true, so it will go into this else block, and I just copy the code and change what variables I want to set. So I want to set B4, 5, 6 and 7, and then I have to set that the first part red is false. So then next time again it will come back and see that the first part red is false, and it will start reading the next byte. So now I need to assemble all the different bits read and make them into a character in a string. Then I want to concatenate all the bytes read into a string, but how do I know when the computer is finished sending the data? We need some sort of convention or some sort of code to indicate that the sending is completed. So let's say if byte read equals 0, then we know that the string sent from the Commodore is finished. So now I'm removing the print commands in the setup because I don't need them anymore, and for every byte read I'm gonna print that byte to the LCD screen. And then when byte read is 0, we know that the sender is finished, and then we can just move the cursor to position 1. Alright, I have hooked up the Arduino and I'm gonna upload the new sketch and see if it works. The Arduino seems to accept the program, and it printed waiting on the LCD, which is text I print in the setup. I have connected all the wires from the user port to the Arduino, and it says waiting, so ready to test. Let's write A, B, C. Alright, so we got a 0. Not much. So in order to find out what's going on, I have connected the sync or the clock wire from the Commodore to an LED. So let me run and see if it's working. Yeah, the LED is actually blinking slowly, so seem to be the correct pulse. So I adjusted the program on the Commodore a bit because I found the one mistake, so I'm running again. Let's see. Now it seems to transfer, for every character it transfers a number. So maybe it's something in the Arduino program. I'm just printing the number to the display. Instead I have to convert it to a character maybe. Okay, I changed my basic program a little bit. I did the wrong calculation of the last part of the byte. You have to convert it to a binary number from 0 to 15, which I've done now from line 400. So I run my program and type hello. Okay, now it seems to work, yeah. I got the correct characters sent. Excellent. Alright, so we know the communication is working, and I changed the background color because it's impossible to film that blue background. And also I changed the delay for every character sent, so it's gonna run faster. And let me type hello world, and let's see what's happening on the display. Alright, excellent. Let me type another text. Now the display should clear itself before the next character. Yeah, and it does fine. Okay. Alright, this demonstrates what I want to do. I'm able to send data from a Commodore to the LCD display, and if you want any of this program, just send me a message. I'll send them to you. Of course, if you know how to program machine code, you could of course make a small program and make it go faster, of course, than the basic program. Also in assembly language or machine code, it's easier to do the bit shifting stuff and moving data to the registers. Alright, next up is using this small OLED display, which I'm currently running the demo sketch for the OLED display. As you can see, this display has two colors and it's capable of displaying graphics and pixels, essentially. Now, OLED displays are much more brighter and also thinner and more flexible, and you don't need a backlight like the LCD display I used before. Now, this OLED display uses an I2C interface, and it's only 4 pins you need to connect to the Arduino. And first of all, you need voltage. In this case, this uses 3.3 volts, so I use a 3.3 volt connection here, and then you connect the ground pin from the OLED to the ground on the Arduino. And then it uses one sync signal and one data signal. So this Arduino actually already got dedicated pins for the I2C sync and data line, so it's the last 2 pins on this side. So that means we actually have all the other digital pins free for doing other stuff. Now, these small displays are very cheap if you buy them from China, which I did, and they come in different sizes. What I want to do is to hook this Arduino up to the Commodore and see if I can use the joystick on the Commodore to draw onto the display. Not very useful, but at least it demonstrates that you can use the Commodore to drive graphics on the OLED display. Okay, for this demo I'm going to use the joystick at port 2, and that is the register at address 56320. So I'm going to read that address continuously and detect what direction of the joystick I'm using. So the Commodore reads the different bits on that register, and it has 8 different directions, which is up and down and sideways, and in between where both the upper and the side switches are on, and the different values for that is this. In addition to these values, you get the different bits set if you press buttons, but I'm not gonna use that now, only the direction. But instead of using these 7-bit values, I'm gonna reduce that to only 3 bits. So what I'm gonna send over from the Commodore to the Arduino is a value from 0 to 8, and I'm gonna encode it like this. No movement or middle is 0, then 1, 2, 3, 4, 5, 6, 7, 8. When thinking about it, this arrangement here with 0 to 8 requires 4 bits, and that's a little waste of the 4th bit, so we don't need actually anything, we don't need to send anything for the non-moving action, so instead I'm going to use these values. which is 0 to 7, and then we just need 3 bits and use 3 pins on the Arduino. So if we send 3 high values, then it is 7. So I already made the first version of the program, and what you see now is a little sprite that I drew, and when I move the joystick, I move the sprite and also print out the direction value. I'm not going to go through all this code, but the important part is this. I pick the address for the joystick register 56320 and the different values, and then I increase or decrease the X and Y values for the sprite and set the direction. So 122 here sets the direction 0, which is up and left. Then I do the same as I did with the LCD display. Is that I poke the user port value and I OR it with 128 to turn on and off the 8-bit like a clock signal. So we get the on and off signal on the Arduino that we can detect with an interrupt. And the last statement here, the data statement, is the bytes for the sprite. Now into the Arduino sketch. To be able to communicate with the OLED display, you have to add a few libraries. So first one you need is the Adafruit graphics library. So you just search for Adafruit GFX. And as you can see, I already installed this one. It says installed. Then, because my display is SSD 1306 type, I'm searching for the correct library to communicate with that kind of display, and as you can see, I found it here and it's already installed. So I use an example that I found. If you go to File, Examples, and you find the library you just installed, I'm using this example here for the 128 x 62 resolution, and the display is using the I2C protocol, so the example uses that. The sketch is not that complicated. I remove most of the example, which includes a lot of drawing routines and things like that. You just include the libraries that you installed, and then you set the screen width and height, and then you make a variable of the SSD 1306 object. Then I call serial begin, and finally we call display begin. And one thing to that is a bit of a problem here is this address for the display. I've seen other examples that are using the address 3D, and actually on the back side of my display it says address FB, but that's completely wrong. So I tried different values and ended up with 3C as the address for my display. On some displays you can configure this address. Okay, next of this setup is clearing the display and then drawing a pixel at position 1010 in the color white. So every time you do a draw operation to the display, you should call display, or at least every time you want to refresh the display. So the next part of the program is to read the input from the Commodore 64, and then we have to parse the input, and then we have to draw pixels for the input. So that's the main goal of this sketch. I'm gonna go ahead and do that now and be back when I'm finished with a working sketch. Okay, I'm back with my sketch, and as the one with the LCD display, I have a couple of constants defined for the pins I'm going to use. I'm going to use pin 9, 10 and 11, and the interrupt pin is number 2. Not all pins can be used for interrupts, but on this Arduino it's number 2 can be used. Then in the setup I added the pin modes, and also attached the interrupt handler. And like before, the interrupt handler doesn't do anything much except set this clock was triggered to true. And then I have a few variables to hold the direction I receive, and also the X and Y coordinates for drawing at the display. And inside the loop I check if the clock was triggered, and if that's the case, then we do some work. I read the 3 pins into B0, 1 and 2, and then I make these 3 bits into an integer like this, and then according to this directional values schema, I have all these if statements that subtract or adds 1 to the X and Y values for the position of the pixel drawing. And also to avoid having values below 0 or the maximum position of the X and Y, I check those and set them accordingly. Then I call the display draw pixel for X and Y, and then call display to update the display. So this should work. However, I didn't test it yet, so it's always exciting to see if it works first time. Let's try. Hooking up the pins from the user port. Of course, you need to have the common ground pin, and then I am using pins 0, 1 and 2 as the data, and pin 7 as the sync signal. Alright, let me turn on and test. Okay, testing. Hey, it draws something. So it seems to be jumping off some pixels, but I think maybe I have some wrong directional value, because it's jumping, but at least it's communicating. Alright, I think I found a bug, and if you see on line 205, I've set the direction variable to 0. However, 0 is used as one of the positions, so I have to set it to -1. because below here I checked that the D is larger than 0. I fixed the bug in the Commodore program, and also I found a bug in the Arduino sketch. So I fixed that too, and now the drawing works perfect, I think. You can draw all directions. The noise you hear is from my joystick, by the way, so it's squeaking and it needs to be lubricated. Not very quick and of course not very useful, but hey, this is a demonstration for learning, and also only your imagination is the limit. So yeah, I think this works great. Alright, that's it for part 4 of this series. I was thinking about trying out the touch display, but as it's made for not for the Arduino, I'm not gonna do that now because it seems to be a lot of research to convert it to be used to an Arduino, so I'm not gonna do that. Also, you can buy a lot of different LCD and touch displays for the Arduino, and they are not that expensive either. So with that I say thank you. This was a great learning experience for me. I hope you learned something too. I hope you enjoyed this series, and hope you'll subscribe to my channel. So thanks a lot and see you next time. Bye bye.